Okay. Hello, hello. Hello, hello. Let me see if I can. Ah, oh no, the live chat is working. It is there, I think. Let me think about where to put it. I guess it can. No, it's gonna overlap with that window. Let's put the chat here. Something like that. Hopefully the code doesn't overflow too far into the terminal. So that should be okay. Forcing everyone to subscribe with subscribers only mode. Alrighty. Okay, so I'll give it like 1 minute. Give it 1 minute and then we'll kick off. How much code are we writing? I'm hoping the lines won't be too long, is what I'm looking for. Because what? I've got about this much space. That's the gutter. Yeah, we might get some overlap. Might have to move the chat around a little bit later. Okay. So we'll get started then. Hello and welcome to, this is going to be like a mini sort of talk, stream, something in between. Feel free to type as much as you like and ask questions or anything like that. But there is sort of, I have a path for this stream. It's sort of not like a, you know, we're starting here and we'll end up somewhere. Hopefully we do actually end up roughly where I'm hoping we do at the end of this. So it's a stream about macros. Well, macros in Rust specifically, but also a little bit more generally about meta programming, the ideas behind it. We're going to be attempting to make a macro rules macro in Rust, which is, well, it's not necessarily simple on its own, but out of all the different types of Rust macros, macro rules macros are the simplest of the bunch. So we're going to be making one of those. And the idea is that this macro should be a... So I forget how YouTube sort of works on these sorts of things, these words and stuff. I'm going to, just to play it safe, I'm going to call this language Brainf. And so we're going to be trying to make a Brainf interpreter in one of those macros. Okay. I've got a whole bunch of things that we're going to sort of slowly look through throughout the stream, throughout the talk. I'm aiming for around an hour, but I think that might be a little that might be a little too keen. It might take somewhere a little more like it might spill over. I'm hoping it doesn't go longer than an hour and a half, but it might spill over a little bit. We'll end up seeing, I suppose. Okay, so where do we start? Well, there's sort of two main topics for this stream, which is macros and Brainf. So it doesn't really matter to me which one we look at first, but I've got Brainf laid out first here in my tabs. So let's have a quick talk about that. So I'm going to make it big. Brainf is an esoteric programming language created in 1993 by Urban Müller. So an esoteric programming language. An esoteric programming language is a programming language designed to test the boundaries of computer programming language design as a proof of concept, as software art, as a hacking interface to other languages, or as a joke. This is generally the one that resonates the most with me. Esoteric programming languages are generally languages that were designed almost as jokes. I don't think there are any real esoteric programming languages that you would genuinely want to use for real software development. I think if that did become the case, it would cease to be an esoteric language and it would just generally be a programming language. I don't know, maybe some programming languages spawned out of esoteric languages. Insert random programming language that you hate here. So I maybe C++. Probably C++ was probably a failed esoteric programming language. Haha, Rust joke. So why Brainfrick in particular? There's if I go to esoteric programming languages, I'm hoping that there's examples here. There's probably a whole list of esoteric programming. List of programming language by esoteric. This is a really short list. I believe there's actually a whole website devoted to esoteric programming languages, and there are tons, like hundreds of them. Why Brainfrick? So Brainfrick is I would argue maybe the most popular esoteric programming language, one of the sort of most not only popular but like recognizable as well. Because it's an incredibly simple language, but its implications go incredibly far. So Brainfrick, didn't finish the word, Brainfrick has 8 commands, and a command is just a single character. So, and the catchy name, of course, yes, that's very true. There are 8 commands, and a command is simply a character in the language. So there's no variable names, there's no other text or whatever, it's just these 8 commands. A lot of Brainfrick compilers will also let you type other text in there, as if you just want to sort of type comments or something. But you don't even need like a / comment or a hash or anything like that. You can just type it in because it's only going to use these characters here. I've written, I remember this is quite funny. I've written a couple non-trivial Brainfrick programs in my time. And I remember I was writing a comment, and I think I included a full stop in one of my comments that I was writing. And my code was so obscurely bugged, and it took me an hour to figure out I'd typed a full stop in my comment, or maybe a comma or something in my comment. And so it was like, yeah, that's a command, and so it's fun like that. Okay, but there's 8 commands in Brainfrick, so let me go through each of them. First of all, there is a right arrow here. Let me zoom in a little bit. There is a right arrow like this. Increment the data pointer. So, okay, what's a data pointer? Brainfrick operates on either a sometimes finite, sometimes infinite tape. Sort of like if you've heard of a Turing machine, you may have heard this kind of terminology before. You can just think of it as a sometimes finite, sometimes infinite array of bytes. Usually it's bytes, so 0 to 255, if we're thinking unsigned, which we usually are. So it's got this, let's say for now, an infinite array of bytes, and it has a pointer that's pointing somewhere in the array. Usually, most Brainfrick compilers will either start the pointer at the very left end or in the middle. We'll decide when we get to that. And we call this sort of arrow here the data pointer. So this tape here with all these cells is the data, and this pointer in the middle is the data pointer. So if your code has a right arrow, it means move the data pointer 1 cell to the right. Right, so go from here to here. A left arrow is simply the opposite. Move the data pointer 1 to the left. Plus, increase by 1 the byte at the data pointer. Right, so we're pointing here. There'll be a cell. I should mention as well, usually the, again, this comes down to each individual Brainfrick compiler or interpreter. But usually the tape of bytes are all initialized to 0. That's the usual case. So if they're all starting at 0 and I say plus, it'll make that cell that the data pointer is pointing at become a 1. If I go plus plus plus, it'll make it go to 1, 2, 3. The opposite of this is minus, which decrements the byte at the data pointer. Right, so I go plus plus plus, 1, 2, 3, minus minus minus, 3, 2, 1. And it's worth noting as well that usually most Brainfrick compilers will implement wraparound addition. So if you say 0 and try to subtract 1 from it, let's say minus here, 0 becomes 255. If you go, 254, add 255, add, you'll get to 0. So it wraps around from 0 to 255 usually. That's what we'll do for ours. So we're halfway through the whole language, right? This programming language, we're halfway through all of its functionality. there is the dot command here, which says whatever we're currently pointing at, take that cell, interpret that cell as an ASCII character, right? So if I go man7 ASCII, there we go. If you've seen the ASCII table before, it basically just provides a mapping from numbers into corresponding characters. So if I said dot and the cell at the current data pointer that the data pointer is currently pointing to had the number 75 in it, it would print an uppercase K. And you've got all your favorite characters on here. Unfortunately, Brainf, as to my understanding, does not have Unicode support, so no emojis. Although maybe you could make it work actually. But anyway, that's beyond our scope. And then there is the comma command, which is sort of like the opposite of dot. Instead of outputting a byte at what the data pointer is currently pointing at, instead we will accept 1 byte of input. So read a byte of input from the terminal and store that ASCII value in the byte at the data pointer. So I'm pointing here, there's the box, and I type in the letter X. X is converted to its ASCII number, and it's stored in that cell there. 75% through the whole language. This is really the special part of Brainf. We have the left square bracket and the right square bracket. And this says, if the byte at the data pointer is 0, then instead of moving the instruction pointer forward to the next command, jump it forward to the command after the matching square bracket command. Wikipedia's description here is actually, of the latter is a little more complex than it actually needs to be, and they note that down here. I can't really cover this up with my hand, sadly, but don't read this. Just read the right closing square bracket as meaning unconditionally jump back to the left square bracket, right? So they actually have a sort of C equivalent down here at the bottom. This is our infinite, not really infinite. Ours in Rust also won't really be infinite, but they have 30,000 bytes here, array, all initialized to 0, and they have a pointer. Their one is starting at the beginning of the array as opposed to like the middle or something. And they say, incrementing this pointer here is right arrow, left arrow is decrement the pointer, plus is get the value in that array that the pointer is currently pointing at and increment it, decrement it for minus, put char, the thing in the array there with dot, get char with comma, so print out or get one in. And this is the one we were just looking at here. And this is the reason I've scrolled down to this now. This is essentially what it looks like. When you have a left square bracket, it says while, and if this pointer is something non-zero, if the thing the pointer is pointing at is non-zero, it will go into the body of this while loop, right? And the body here is really just going to be like, if I have a bunch of stuff and then a closing one, it's going to mean like go and do all these instructions here until eventually it will get to this one here, unconditionally jump back to that, and check the current byte at the data pointer again. And eventually, hopefully, unless it's an infinite loop, this will eventually end up being 0, and it'll continue on to whatever other commands are, out here. Right? It'll continue on this way by skipping past. This is also interesting because you can have nested square brackets. So something like this. And this is just like a nested while loop in C. This square bracket matches with this one. This square bracket matches with this one. Okay, and that's the whole language. Really, the whole thing. So why are we interested in the first place in a language that's got this little going on and is this simple? The general answer here is that it is fully Turing complete, which essentially means that this is going to be a drastic oversimplification, but you can basically compute arbitrary things. You can create arbitrary programs with in Brainf. So if you have some sort of like really complicated algorithm that does all this super smart stuff and it took you 100,000 lines of C++, as long as your input and output follows what Brainf can do here, which is essentially outputting bytes and input and accepting bytes of input, which I think realistically most programs can eventually boil down to, Brainf can compute whatever you computed in those 100,000 lines of C++. It's incredible. This was a lot of work in the 1900s went into sort of the theory behind computation. And this is just about the most minimal language you can have that is Turing complete. In fact, it's quite a model representation of a Turing machine in the first place. But the really interesting point is that basically a Brainfrick program can compute just about anything. So if I look at a Brainfrick interpreter written in JavaScript on the web, you can see here I've loaded in this program, which is, pluses. So increment the data pointer. We've got some sort of a loop going on here with all this stuff inside, moving the data pointer around, plusing, whatever, all that stuff. And when you run it, it prints out hello world. Like this program is hello world in Brainfrick, which is just incredible. I haven't looked at a whole bunch of these. Beer.b sounds interesting. Look at that. This program does the whole 99 bottles of beer on the wall, and it prints out the whole sort of song from 100 to 0. Quine. That's good fun. This is a program that prints out its own source code, which is a really fun. If you want to have a nice challenge, on a rainy day, grab your favorite programming language and try and write a Quine, a program that prints its own source code. And you're not allowed to just read the file, no reading your own file and just spitting it back out. You have to do it all within the code itself, which is very cool as well. But there's all kinds of interesting things. This is a Sierpinski triangle, it looks like, which, oh wow, the program has been written to look like a Sierpinski triangle, and it prints out a Sierpinski triangle with out of stars, which is very cool. There's all kinds of, brilliant examples of Brainfrick programs. One really great one as well is this. This is a Brainfrick interpreter written in Brainfrick. So the task that we're about to do in Rust, someone has actually built a Brainfrick interpreter. So this reads in Brainfrick characters on standard input and then executes that as Brainfrick code and spits out the output. So the brilliant thing is once we write our interpreter, we'll be able to feed this Brainfrick code in and then feed in Brainfrick code into that one, and then it'll go through and and do that work. So this is very fun to play around with. So that's Brainfrick. And next we'll have a little look at macros. So will our Rust macro be translating/transpiling Brainfrick to Rust code, a bit like that C table? That is absolutely right. Yes. Okay. Cool. So, macros in Rust. What is the idea of a macro? If you've used Rust a little bit, you may have seen macros around the place. You've probably used macros a lot, whether you know how to write one or not. And they're an incredibly powerful tool. They're, of course, a tool that can readily and easily be abused, as I am certainly guilty of many a time. But they are a seriously powerful tool that often you don't really get. There's a lot of mainstream languages don't have this kind of functionality built into them. If you are something like a Lisp programmer, if you like Lisp or any of its any Lispy sort of spin-off, then you're probably very familiar with this kind of idea. And if you've used sort of C's hash defines a little beyond just sort of trying to hash define constants, you may be you may have played around with the idea. And it's all a similar sort of premise. The premise is a macro essentially is a function that takes in source code and spits out source code, right? It's a function that you type source code into, and it will actually spit out probably new source code, different source code, right? Okay, let's make a new cargo project so we can start to play around with some stuff. Let's do cargo new, Brainfrick. Nice, cool. Okay, don't mind my editor just going crazy in the background there. So notice I've just created a new cargo project and there's already a macro here. How do we know we see a macro? It's this little bang symbol here. So if it was just println here, this would be a function call. Println would have to be a function. Whenever you see the bang character after something that looks like a function name in Rust, it means what you're calling is a macro. So println is a bit of a gnarly macro. There's a lot going on with it. But let me show you a more simple macro in Rust that you'll have used if you've done sort of even relatively basic programs in Rust, and that is the vecbang macro. So if I say let myvec equals vecbang of 1, 2, 3, and then let's change this println here to be, let's print out myvec, oops, like that. Let's see what this program does. If I go cargo run, you'll see it prints out 1, 2, 3. So vecbang is a macro that takes in some source code like this and generates us a vec. In this case, I've got a vec here of i32s. A vec is, if you've played around with other languages, it would be called array list in Java, list in Python, vector in C++. If we need some more equivalent, if someone sort of needs help translating to their language, I can try and have a think. In C, you would probably have to implement something like this yourself or pull in some sort of third-party library. But it's basically just a container that lets you store an arbitrary amount of values in it. You could have nothing in it, you could have 50 things in it, 100 things in it, on and upwards, and it can resize dynamically. So you can just keep adding more and more things or take things away and so on and so forth. So yes, and the f-string thing is actually quite new. Okay, so how would we create a vec with the elements 1, 2, 3 in it if we didn't have this vecbang macro? I would have to write something like this. Let mute myvec equals a new vector. I would have to say push to the back of this vector 1, push to the back of this vector 2, push to the back of this vector 3. Right, this will do the equivalent code. So if I print this out here, you'll see I get the same output, 1, 2, 3, 1, 2, 3. These are, well, it's very slightly not true based on this being a slightly complicated macro on the standard library, but for our intents and purposes, this is essentially the truth here. The interesting thing though is this myvec, I didn't have to say it was mutable, right? So if I went to say, let me try and push 4 onto the end of this vector, it'll say, no, I can't do this because you didn't declare it as mutable. But if I try and do it here on this vector, it's perfectly happy with it, which is maybe not something that I want. So I can actually restructure my code a little bit here to look like this. Let mute myvec equals, and then I create a new block here. I'll grab all of these. Oops, that's not what I wanted to do. All of these and put these in the block. I'm going to call this one here let temp vec equals vec new, and then I'm going to put temp vec at the end here. These of course are all going to need to change to, oh, it's being weird today. Let's do this, temp vec, great. And I'm going to need a semicolon at the end here. There we go. And I'll need a mute. Okay, so what this code here is now saying is, where's my gutter not going smaller? Anyway, create a new temporary vector with vec new, and it's going to be mutable. Push all these elements into it. And then this here at the end, this is something that you may not see in a ton of other languages. You may be familiar with this if you come from languages like Ruby potentially. Notice this doesn't have a semicolon on the end of it, right? If I put a semicolon here, Rust is still happy with this, but it's just going to print out nothing at the bottom here. When I get rid of the semicolon, you'll see it prints out this. So this not having a semicolon actually means something important. What it means is, since I say let myvec be equal to this block of code here, right? This block of code here, myvec is going to end up evaluating to this temporary vector at the end of it. So you can almost imagine this as saying myvec equals do all this stuff, but like really this thing at the end. And notice I've gotten rid of the mute here. So if I then tried to say myvec.push 4 on the end now, it'll say no good. It's not mutable, and so we're back to sort of where we wanted this originally. If I actually wanted to do that, I'd have to put a mute out the front here, and then it would be happy to put the 4 on the end there. So let's imagine we didn't have vecbang and we wanted to write it ourselves. because this is a bit of like, this is annoying to type if you want to do this like a lot, which you often do in Rust. You want to create a bunch of vectors with stuff already in them and all that. So this is going to be our first macro. To declare a new macro, we write macro rules, and we need to give it a name. I'm going to call it, I want to call it myvec because we've already used that there. I'm going to call it DIYvec because we're doing it ourselves. All right, and this is the general syntax for declaring a new macro. So we start with macro rules, and this is a simple macro. There's all kinds of special macros that you can read about all yourself. But this is the simple form of macro. The name of the macro is DIYvec, and all this stuff in here is going to be the contents of this macro. Macros are made up of things called rules. So this here is a single rule. It has some parens there, it has an arrow, and then some braces and a semicolon. We can have as many rules as we want. So I can go rule, 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 and make a whole bunch. And these might match sort of different inputs to the macro, which we'll see in a second. Why would you want to do it with the block as opposed to just shadowing the early my vector? Or is this just because it makes more sense with the macro? Yes, you absolutely can shadow it just like that, and that will shadow away the mutability. And yes, you have noticed that this is it makes the translation to the macro here a little more clear in a second. So you're absolutely right. Okay, so how does this macro syntax work here then? Well, like I said earlier, a macro takes source code, right? It takes source code and then it spits out more code. And in this case, the source code that it takes in doesn't necessarily have to be like valid Rust code, right? Like if I just typed in 1, 2, 3, 1, 2, 3, Rust is obviously going to get upset at this and go, I don't know what this is, right? So it doesn't have to be actual Rust code, but it does need to tokenize, which is a bit of a weird fancy word. It means that Rust's sort of very first stage of the compiler needs to be able to make a little bit of sense of it. But as long as it can do that, as long as it can break it into sort of little tokens and stuff, then you can pretty much go buck wild on what you include in the body of a macro. And generally, a macro, however, needs to spit out valid Rust code. The macro needs to spit out Rust code, which it'll get turned into. Okay, so how do I actually take things in here? Well, let's say, have a look at this. Let's say I wanted to make a macro that will say, if I have equal, 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 if I type that in, I wanted to spit out some code. Let's say spit out some code that prints, and it'll say equal, I don't know, something like that. But if it sees the tokens, let's say minus, 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 something like that, then it'll go println, oh my god, minuses, something like that, and a semicolon on the end, just like that. So if I wanted to use my DIYvec macro rules here now, I could pass it equal, equal, equal. I could pass it, oops, minus, minus, minus. And if I run this, you'll see it prints out equal. Oh my god, minuses. But this is the very tricky thing to see here. This is not calling this macro at runtime. When I run the code, it's not going and like passing in the equals like a function would and saying that. This is all done. This is all substituted by the compiler. So a really nice way to get your head around this sort of stuff is with the cargo expand crate here, jumping ahead a little bit. So cargo expand is made by the legend himself, David Tolnay. And if I run cargo expand, so let me move this away for a second. And where am I? I'm here. If I run cargo expand on this, cargo expand will take all my code and expand away all the macros. So in this case, notice this code hasn't been run yet. This is my code here, but the code at the top here is no longer equal, 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 minus, minus, minus. That stuff is all gone. Instead, it would have been turned into println bang, right? But that itself is a macro, and so that macro is expanded into this code. And this code here says print with the word equal or print with the word, oh my god, minuses. If we also look a little further down here, this is the vec bang code here. Notice we have let my vec of I32 equals, all that will stay perfectly intact right there, but this vec bang, with all this stuff inside it, has turned into this code here, right? It's a little complicated, but we'll make a simpler version of it and see this happen ourselves as well. So cargo expand is very nice for looking at how macros sort of end up. Does it care about white space? Could you do dir vec minus minus minus? So let's have a look. Minus minus minus. And if I run it, oops, not pwd, cargo run, it still says equal, oh my god, minuses, right? So it is white space agnostic, but you have to consider that sometimes the white space will affect how things tokenize. So for example, if I wrote hello and world, this is two separate tokens, the word hello and then the word world. In this case, we'd call them idents as opposed to words. If there was no white space here, this would just be one token. A little more sort of like code-like and a little bit less, maybe a little less obvious, is if this in fact here, well, let's say if I did equals and then a greater than arrow, if I write it like this, then these are two separate tokens, equal token and then a greater than token. But if I did this way, then it's an arrow token like this. So the white space can affect the tokenization, but if it doesn't affect the tokenization, then then the white space doesn't matter, if that makes sense. So the one thing I wanted to point out here is, what if I give it something that it doesn't like just foo? Then we'll get an error. So if I go, cargo expand, which will build my code, it says no rules expected the token foo, no rules expected this token in the macro call. So when calling DOI vec, it didn't know, it went through this rule, it went through this rule, and it got to the end and went, I don't know how to deal with foo, and so it gave up. So again, to recap, macro takes code in some format and spits code out, and it spits Rust code out. Okay. So how can we actually make this do anything vaguely useful, let's say? So let me grab this one back. The idea here is that we don't need to just put actual tokens here. Like I've written actual equal signs and actual minus signs, but I can put sort of, we call these captures, variables that represent some kind of token. So if I go to the macros book here, we'll go to the next one here, which is the Little Book of Rust Macros, which is a very cool little book. You can Google for the Little Book of Rust Macros and you'll stumble upon it. And it basically goes through a whole bunch of trickery and information and all that about macro rules, macros in Rust. And I'm going to go to the macro rules section, which I believe is, where to go? Here, macro rules. And if I scroll down a little bit, we'll get to captures here. And these are special things that we can capture within our macros. So hash divine, but you can't shoot yourself in the foot quite as easily because you've got to get through the compiler first. That's true. Rust does some nice things like they're partially hygienic and stuff, which I'm not going to get into in today's little stream here, but they're a little more robust than something like a C hash define. Does doing dir vec bang minus 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 with square brackets work, or does it have to be parens? That's a great question. So if I, oops, that's not what I want to do. If I swap these for square brackets, oops, replace with square brackets like that, does it still work? And the answer is yes. So it's actually convention how you call your macros, and you can choose one out of parens, square brackets, or braces, and Rust will always be fine and happy with it. So that's just completely conventional, and to a certain point, it also comes down to like preference as well. All right, so let's see, how can we use this to make our vec macro? Well, if I look down here, I've got an item, which might be like a function, a struct, a module, a block, a statement, a pattern, an expression, a type, an identifier, a path, a meta item, or TT, a single token tree. This is a really fun one that we'll come on to later. But expa is the one we're looking for, an expression. So in our case, things like 1, 2, 3 are expressions. you could also have like 1 plus 2 plus 3. This all forms one expression. The expression is 1 plus 2 plus 3. And then we have a comma, 2, comma 3. This is one expression, another expression, another expression. So what if I said, instead of sort of this stuff here, what if I said I wanted an expression? The way I'd write this is I'd say dollars and then some name. I'll call it my expa. And what type of thing is it? And that's one out of this list here. In this case, it's going to be an expa. All right, so this is suddenly unhappy because it's going, this is not an expression, and like having a little freak out. But what could we do with something like this? Well, what if I did say println bang, println bang of my expa here. So let's change this for DIY vec of 1 plus 2 plus 3, like that. And you'll see the compiler seems happy. What's going to happen if I cargo expand this? Right, I'll move this away, bring this one. Oops, I sent it to the wrong screen. Where'd it go? Here. We have this one, this one. All right, cargo expand. You'll see that this here turns into print, like this is the printing stuff from println, blah, 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 1 plus 2 plus 3. That's where the tokens ended up. Right, so it's a little confusing because we've got the println macro going in at the same time here. But we end up with 1 plus 2 plus 3 at the end. How interesting. So again, we're taking in some form of like code, doesn't necessarily have to be exact Rust source code, and we're spitting out Rust source code that may include that sort of stuff there. The thing that really gets us where we want to be for our little vec macro here is repetition as well. So if I go down here, patterns can contain repetitions. These allow a sequence of tokens to be matched, and they have this general form. So if I said I don't just want one expression, but I want as many expressions as you want to give me, right? Think in this vec macro, I can just keep going comma another, comma another, comma another, comma another, so on and so forth. Then I can wrap all this in $parens like this, and you see my editor turns them red. And after this, I have two things I need to specify. One is optionally a separator. So very commonly, you might want to do something like a comma. And then how many is valid for this macro? So is it okay to have 0 and then 0 upwards? Or do you only want 1 upwards? Well, if we think about our macro here, is it okay to do vec bang of nothing in it? The answer would be yes. That'll just give you an empty vector with no items. Or alternatively, you can start, adding in more and more and more as you go. So I'm going to say star, which if you've seen regex syntax follows the same sort of idea, which means 0 or more separated by commas. I could not put a comma here, and that would just mean separated, generally by white space. But sometimes, often the compiler isn't super happy to try and group expressions by white space because you can get parsing ambiguities, and it's a real big fun time. But so I'm going to use commas because that's what the standard vector macro does, separates each item in the vec by commas. So that's what I'll write here. And now the syntax for this becomes a little interesting. Let's say I'm just going to say I'm going to print each of these expressions out on their own line still using the println bang macro. The way I write this is I do, following the outside syntax here in red, I do dollars with the star on the end, like this. And then inside I put some code that will be repeated, and it'll be repeated for each of my expressions here. So if I say println bang of $my expression, with a semicolon on the end, then it's all happy. And let's see what this looks like. And 7 plus 8 plus 9, like this. Let's grab this one back and cargo expand it. You'll see that it turns into a println bang of 1 plus 2 plus 3, a println bang of 4 plus 5 plus 6, and a println bang of 7 plus 8 plus 9. Right? And these semicolons here, for example, are coming from this one, and this one. And so it really is turning this arbitrary stuff we've written into new Rust code. And if I run this, just to show, it'll print 6, 15, 24. Right? So the addition does happen, but in this case, it's happening at runtime because that's the way we've typed it in. Okay. So how do we actually get to what we want? We wanted to create a vector with these values in it. And the answer is, for the most part, we're just taking this code and thinking about what should happen each time, right? So what should happen for each expression and what should happen only once. So realistically here, we're going to get let my vec equals and then vec bang. So we're starting from here. So let me get rid of, well, actually, this code is actually already correct here. So we're going to empty out this body here. Our macro really starts off right here. And in fact, we do end up needing to put that brace in ourselves. The semicolon actually comes from them though. So notice this semicolon is here, this semicolon's here, and this after the equal sign, that's where the macro lives, right there. So we're trying to generate all this code right here, if that makes sense. So what happens only once? This part here only happens once. So I'm going to write that in. Let mut temp vec equals vec new, right? This at the very end, that sort of like almost returns back in a sense, sort of returns our temp vec at the end, only happens once. But each of these pushes, we want to do one push for each expression. So what do? We write that same syntax that we saw before, and we say temp vec dot push with that expression, my expression, like that. So let's see if this works. I'm going to say, let's comment out this code and say let my vec equals this DIY vec 789 like this. And if I say cargo run 6:15:24, right? There's our macro there. If we look at cargo expand, this is the very cool part. If we look at cargo expand, let's match this up. Let my vec equals, right? Let my vec equals, then this brace here comes from here. Let mut temp vec equals vec new, that's this code here. For each of the expressions that we gave in, it's going to call temp vec dot push, so that's the 1 + 2 + 3 here. Then a comma, this comma separates individual expressions. The next one, 4, 5, 6. The last one, 7, 8, 9. And then finally, this temp vec comes here. This closing brace comes here, and that's our semicolon. And we've successfully written some Rust code that does something useful. I mean, not useful for us because we've already got the standard library to do it, but it's actually doing something meaningful at least. Okay, how interesting. There is one interesting thing though, which is Rust functions, right? If you're actually calling a real function like println, they're happy for you to leave trailing commas, right? So this looks nice generally when, if I use like the standard library vector, if you have your field separated out like this, it's nice to have a trailing comma on the end, so it's all the lines are sort of consistent with each other, and it means adding a new line is just going, create a new line and do 1, 2, 3 comma in this case, instead of having to modify this to add a comma and then type in this one. You'll notice that if I put a comma in our macro, oh no, suddenly it's not happy. If I try and build it, it says unexpected end of macro invocation. It says when calling this macro, I don't know how to deal with this comma. Oh no. Fortunately, we can actually deal with this. The little book of macro rules says that currently you can only repeat either star 0 or more times or plus 1 or more times. You can't write 0 or 1. Turns out you actually can. This book might be a little outdated. I might need to submit a PR or something afterwards. There is this RFC, which is how changes make their way into the Rust language, that added the question mark repeater here, which means 0 or 1 if you've seen that in the regex as well. If we go to the tracking issue, you'll see that it's closed, stabilized. It's in, I think it's been in Rust since about 1.25 or something like that. The issue was made in 2018, so around that point. So we could actually say at the end here, put a new thing here, which is like, think of looking at it like this. This is another sort of token here, and we'll say a comma optionally. So we'll match a comma token 0 or 1 times. If I write the file, you'll see that our error is now gone. If we run it, you'll see it does the right thing. So this is the one other repeater. There's star, which is 0 or more, plus, which is 1 or more, and question mark as well, as of Rust 1.25 or so ish, which is 0 or 1 as well. So it's worth checking as well. Does it work? Does our macro work if I don't give it any? DIY_vec, and maybe we like to use square brackets, something like that. Let my vec equals that, and then print it out. Let's see, do we get an empty vector? Oh, it doesn't know what type of vector it is. That's fair. We'll say it's a vector of I32s, doesn't really matter. And we'll see there's an empty vector there. So it does work for that. If I had have changed this to a plus, then it actually won't build because it's expecting at least one expression here. We're happy with 0 or more, so it does work. But something rather interesting happens as well. We get this warning. Variable does not need to be mutable. Temp vec. Help, remove this mute. What? That's weird. Let me remove the mute. Oh no, we can't push to the vector because it's, consider changing this to be mutable. Mute temp vec. Like, you just told me to remove that. And so it's, this one's just a warning. So, okay, this one's probably the wrong one, but it's giving me conflicting advice here. So, hey, let me catch up with this. How limited is a particular type of macro thingy? E.g., can you do stuff like repeat the dollars bracket star to do multiple things for every expression? Can you find the number of expressions in the list? Yes and yes. So generally, you'll see that when macros call themselves recursively. The first one, rather, you can actually just sort of do things twice. Like if I grab this code here and paste it again, this will just push twice for each element. So if I go cargo run, you'll see we get 6, 15, 24, 6, 15, 24, right? Because it'll push all of them and then push all of them again. For the second one, could you count how many things you can? Yes, you can. And there's maybe I'll leave it as an exercise after we write our own recursive macro for Brainf. Hello, Jashank. The Lisp summoning worked. Yep. And so vec bang of comma works okay. Oh, that's a very interesting point. So for ours, it absolutely will in my mind. Yes, I'm not sure about the standard library vector. I actually don't know. Let's find out. No, interesting. So they don't like an empty comma. So I do know how they've chosen to do this. It's a way that's a little more complicated than just throwing an optional on the end. But we'll leave ours like this for simplicity. It's an interesting sort of difference between our implementations, and probably the standard libraries makes a little more sense here, but we'll leave it there for now. Okay, so what was up with this? What's up with this variable does not need to be mutable when it clearly does? Let's go into cargo expand one more time and have a look at what it's saying. So cargo expand is actually complaining about our first invocation here, right? So notice on this invocation, which is right here, it says create the mutable vector, push, 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 and then spit it back out. Our first one says let mute temp vec equals vec new and spit it back out. It makes sense that the compiler is getting upset about this because this doesn't need to be mutable. We don't ever change it. We just create it and then we spit it back out, right? And this really comes back to the idea that our macro is really spitting out Rust code, and that Rust code gets fed back into the compiler, and the compiler will sometimes complain about that Rust code because this doesn't make sense, right? And so this is actually a trick that people often do when writing macros like this. This is a fun one. So they'll prefix their variable with an underscore, right? This doesn't actually have any semantic meaning to the compiler. It doesn't treat things with underscores specially. There's one very strange case with a single underscore on its own, but that's for another day. It doesn't treat this any differently, but it signals to Rust that this variable is not used, which is also not quite what we want. In fact, there is supposedly a Clippy lint, if I find it, here, that says if you have a variable that starts with an underscore and then you use that variable, Clippy will complain at you. It'll go, you said it was underscore x, which is meant to mean you don't use the variable, but then you actually did use it. And so we get to the final solution. People often prefix with 2 underscores like this. So they'll say underscore underscore, which is like this. This is a common pattern in the community, and that tools generally recognize. That means it's maybe used, just like it's sort of, it might be used sometimes, it might not be used other times. Don't make any assumptions about whether this should or should not be mutable. Just don't warn me. I know what I'm doing. And so tools will often pick up on this. And I wonder if Clippy actually says, it doesn't work properly with macros. It's been allowed in the meantime, blah, blah, blah. They say a single leading underscore is used to this. So they actually, it's not really written here for whatever reason, but the way around that is to go double underscore and then, yeah. Wouldn't one unused mute inside the macro be better though, like the compiler suggested? Yes, you absolutely could do that as well. So if we want to change that, we could do, instead of this, throw in an attribute here that says, it wouldn't be warn in this case, it would be allow unused mute. Like this. And, okay, yeah, it popped up for a second. I was like, oh, that's weird. Oops, not cargo expand. And you can see now that's also happy with that. But you sort of may see both approaches in the wild. It's a little fun like that. But yes, this will work as well. So maybe we'll leave it like this. Rust was meant to be different Python than underscore. Yes, that's very true. Fortunately, it's generally just used to signal a bit of intent occasionally, as opposed to, at least it doesn't have any sort of semantic meaning. Okay, so we've made our DIY vec. It's a little scuffed. It's a little, rough around the edges, but it gets the job done, right? And this will work with whatever expression we give it. If we give it something completely, gnarly, like let my vec equals a DIY vec of, and let me just like absolutely torture test it. Like I'm going to go the string hello dot, I'm not going to get language server completion. So let's do it here. Let's turn this, into, no, not into it. We'll do, why is it not giving me, sorry, chars. We'll take the chars. We'll map each character dot to uppercase. We'll filter out so we don't find any characters that are equal to E. I don't know, we'll collect that back together into a string, something like that. And we throw this into our macro here. Right. It's upset at me because, great. This is a fun thing about macros. They can be really, two uppercase, two ASCII uppercase is what I think I want. Two ASCII uppercase like this. And hopefully you can collect that. Why? You don't want to compare that, so I'll do this and then collect it together. Great. So this here is an absolutely gnarly thing that in my mind is going to turn into capital HLLO, something like that. You don't really need to understand what all this is doing. But if I go cargo expand once again, you'll see that literally all it does is it goes temp vec.push and then spits all that code I wrote, which is one single expression, where I told it to spit it out right here in these parens here. And if I run it, cargo run, you'll see I get capital HLLO. So it passes the torture test. It's a very sort of flexible system without having written a whole ton of code. Okay, great. So we've got a whole bunch of garbage going on here. Let's get back to Brainf. That's what I'm calling it. That's the one. All right. So this is the meat. I'm going to create a new macro here, and it's going to be called, I'll just shorten it to BF, like I've sort of seen before. And it's going, oh, I don't know you didn't give me any rules. Okay, I'm sorry. Okay, great. And so we've got our macro BF. The idea here is okay, it turns out we're an hour and this might end up going for more like 2 then, sorry. The idea of our string here is that I want to make a Brainf macro that takes in Brainf source code. So actually, let me grab you an example here. Something that looks like this. That looks like this. Right? And I actually type real Brainf source code into my Rust program, and I want the Rust compiler to turn this into actual Rust code that executes this Brainf for me using a macro rules macro, right? So this is hello world. This code here is hello world in Brainf, and I want to write a macro that turns this into real Rust code that when that Rust code is run, it does, it sort of like, it acts in the same way that the Brainf code would. I'm watching forward at 3x speed, and on the earlier topic of miserable brain fork implementations, there's one written in Sprintf. Oh, yes! Yes, Sprintf format strings. Yes. There's all kinds of people have done some seriously brilliant things with Brainfrick. I think we'll do something, relatively cool today. But there's a whole world of fun that's gone on in Brainfrick. Okay. So, how do we get started? We're going to use a specific technique to make this macro, and this technique is called incremental TT munches, which sounds like oddly might make you hungry if you work on incremental TT munches too much. But the idea here is we're going to make a macro that's recursive. Oh my gosh. So how does a macro that's recursive make sense? Actually, here's a really fun one. Who was it that asked? I want to say it was Evan. I'm scrolling the chat. Yes, Evan asked this question earlier. Could we write a macro that counts the number of things? And the answer is yes, we could. Let me comment out this Brainfrick here. And actually, it's a relatively simple recursive TT munching macro. So if I create a macro that's called count, let's say count expers, and like before, it takes in some expressions, let's say separated by commas, something like that. Sorry, oops. Sometimes I get the dollar backwards. So the name of our variable is exper, and it's of type exper. In the previous one, we just wrote it as my exper, but this is fine as well. And the trick here is when they give me this whole bunch of expressions, I'm going to create a counter. And this counter I'm going to call I, and it'll be equal to 0. Okay. I will be equal to 0. Actually, this doesn't need to be recursive. Oh, that's sad. So, okay, well, yeah, that's a little sad. This one, in this case, it doesn't need to be recursive because I could just write something like this, where I say for each of the expers, ignore them, and then I plus equals 1, like this. And this would end up counting the expressions for me. I also have to make sure that I give them I back at the end of this by doing this, like that. And this would end up counting them for me. And how would it do this? Well, let's actually give it a run and do a cargo expand. I call this count expers, and I give it like hello 123, an array, just any kind of thing that you can think of, string new, whatever, something like this. And I said let x equals this. Oh, actually, an array is not really. It needs to know what's in the array. Let's just say like 100, let's just say the number 1. I don't know, something like that. Like this. If I go cargo expand, you'll see that it just goes I plus equals 1 plus equals 1 plus equals 1 plus equals 1 and spit I back out. So if I actually go println, I can give it, I can print out x, cargo run, and it'll print out 4. So I actually don't even need to be recursive. Why did I do let underscore equals $x bar? The answer is, if I remove this, it goes, I don't know what this is meant to be repeating for each thing. Right? Because I might have multiple things that are repeated. If I had a semicolon here and then said, I want a whole bunch more expers over here, then it wouldn't know if I should repeat it for each of these things or for each of these things. So I say, we're repeating it for the expers, but I'm not really doing anything with them. So I just basically chuck them into the void, which is a little bit of fun there. This is also not quite what we want either, because it'll end up evaluating things. If I made one of these be an expression that prints some stuff, it'll end up printing it out as well, which maybe that's what you want, maybe it's not what you want. But this is just a simple example anyway. All right, I guess we'll go straight into some like recursive definitions then, which are, again, some very good fun. So what's going to be our approach for this BF macro? Well, what tokens, like what are we expecting to come in here? If I go back to the list over here of what we're allowed to capture, it can be an item, which is something like a function, a struct, or a module, or something like that. This is like a declaration that may go at the root of the file somewhere. A block, that's not kind of right. Like if we're just having plus dashes, that's not a block. A statement is a whole like statement of Rust code followed by a semicolon. That's not right. A pattern is used with like pattern matching and stuff. That's just wrong. An expression, well, plus, if I do plus, minus, comma, left, left bracket, that sort of stuff, those aren't expressions either. They're not types. Identifiers, that's like foo, bar, baz, that's not right. A path, that's a path like, stood, mem, replace. No, that's not right. A meta item, things that go inside. Okay, that's very specific. Like, no, still not there. And finally, we're left with TT, a single token tree. TT, what is TT? So, token trees is the idea that if I have like some stuff, let's say some stuff encased in, what's a good example of this? This sort of like, to really understand a token tree, you have to understand what something called an abstract syntax tree is, which is a little beyond our depth in this little stream here. But the idea is it holds, if I wrote something like, what could be taken as a TT? Let's say something like parens 1 plus 2 plus 3. I believe this here would parse as a single TT, single token tree, and it would look something like we have a paren and then a 1 plus 2, and then that gets taken and plussed with 3. It sort of evaluates to one sort of, it's a tree of tokens, one sort of grouping, let's say, of tokens. And that ends up being really convenient for us because there aren't really any groupings until we come to these square brackets, and it's actually going to make our lives a whole lot easier. But these are all just individual tokens, really. A plus, 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 a right angle bracket. These are individual tokens. So if we say that we can have some, a TT, right? Sorry, let's call it tokens, which is a TT, and then say repeat a whole bunch of these separated by, commas, semicolons. Doesn't really need to be anything. So we'll just say we don't need a separator here. Then this will basically match all the tokens that we give it. So if I went, there's a really cool macro called stringify, which basically takes any syntax and turns it into a string of that. If I said stringify those tokens and then print them out like this, what would it look like if that was my BF macro here? Well, let's see. Variable tokens. Oops, sorry. Tokens is still repeating at this depth. Let's go for each of the tokens then. We'll print a new line. Something like that. Is it happy? Yep, it's happy now. Cargo run. You'll see it prints out each of these individual tokens. A minus, a dot, a plus, so on and so forth. Interestingly, sometimes it groups tokens together. This is I believe, a left pointing arrow. This here is, like a bitwise shift. Where's some other good ones? Dot dot is sometimes used in patterns and stuff. So occasionally these get grouped together. And if we have something like these square brackets, it'll find the matching square bracket, right? An interesting thing in macros in Rust is that parens, square brackets, and curly braces need to be balanced, right? You can't just have open paren, open paren, open paren inside your macro. They need to balance out or it'll reject it. And this all gets sort of spit together as one token tree, one TT altogether, because it starts at the starting one here, finds the end one, and then it's got all these sort of tokens inside the TT, inside it here. So this sort of splits up our Brainf program. Mostly. There's some edge cases to look at here, but let's sort of pretend they don't exist for now. Let's say we did something like, after each token, we put a space or something, so it really made sure that they're all separate. We're actually going to find a way around this. And I'm sure there's a really brilliant way to do this in Vim that I don't really care about. So you can watch me as I separate all of these by spaces. And when I run it again, you'll see that these all get treated as individual tokens. All right, let's just say I did that just to make Jashank specifically angry because it would. And you'll see now we don't get any of these groupings together. We don't get this turning into some sort of like bitwise shift with the two next to each other. We still do get the brackets grouping because, again, that's a sort of requirement of how macros parse in Rust. So this ends up being one big tree. Okay, once again, how does this still help us though? Well, if we can sort of think about these characters one by one, right? If we can think about them one by one, then we can actually turn it into a little bit of Rust code, each individual token into a little bit of Rust code that does the equivalent of what that Brainf command is meant to do, right? So let's say over here, I create a new tape. We'll say let tape equals, we'll make it a vec, that's fine. We'll make it a vec of unsigned bytes, U8. And let's make it from an array. Starting off with 0, and let's say, how big should our tape be? Maybe like 2048, something like that. 2048 bytes. It's not going to be an infinite tape, right? But it's not super finite either. That's a fair amount of bytes. And we'll say our pointer is going to be, I think the pointer should start somewhere in the middle, so you can sort of either work forwards or backwards and it'll still be roughly happy. So I'm going to start my pointer off as if it's pointing in the middle of this array here. Then we could say a plus turns into, you know, I believe a plus would turn into tape of pointer plus equals 1, right? I could say a right arrow, right? A right arrow here would just turn into pointer plus equals 1, right? Look at the next index. There's sort of little bits of Rust code that we can turn this all into. Unfortunately, it's not quite this easy. We can't just start turning this stuff here into tape do this, pointer do this, because macros are hygienic in Rust, or at least they're partially hygienic, which means that if you spit out code in here that talks about this tape variable, it's going to assume you meant a different variable. They sort of are limited, sort of variable scopes are also limited in the sort of areas of code generation, let's say. So you can't just willy-nilly use random variables all between macros all over the place. You need to be a little more structured about it. So we can do that though. We can say that we have, let's say the tape, which is some sort of ident, right? And then maybe I give a, I'd like to use a comma, but that might get confused with some Brainf syntax, which actually uses commas sometimes. I'll use a semicolon, and then I'll say the pointer, which is also an ident, and then another semicolon, and then all the Brainf code over here. So if this way, I could pass it in as tape semicolon, pointer semicolon, and then all the Brainf code, and this will work fine. It'll be able to talk about tape and pointer through these. The macro hygiene will be happy about that as well, and we can start to actually like make it do some real things. Let me just catch up here. All right, so that's how they. Also, that's how they figure out what to repeat. I was thinking it was just order. So it is order. I'm not sure if the question is the exact one here. The macro will look through the rules top to bottom. It'll sort of like look at the first one, then the second one, then the third one, and it'll try and match whichever one matches first. And we're going to exploit that for what we do here as well. I'm not sure if that's the exact question you were asking though. QR arrow A space escape L or bar. Q would be the Vim macro. Yeah, well, oh wait, yeah, actually I do know how to make macros in Vim, but you know, it's all right. It'll make Jashank upset. That's always a win. Okay, I'm sorry, I'm kidding, Jashank. So let's work on our first little part of our BF macro. So this here is if we have, this is a whole bunch of tokens. Let me just look for the case where we find, what was the first one on our other list? Over here, commands. The first one was a right arrow. So how could I do a right arrow in this macro? Well, if I wrote $tape is an ident, so that's always going to come first. This pointer, which is also an ident, will come next. And then specifically the case where we get a right arrow. And then there's going to be a whole bunch of stuff after it, right? It's, you know, if we parse this thing, there's still going to be all these tokens to come next. So I'm going to say there'll be a whole bunch of tokens next. I'll call it the rest. And this repeats as long as it needs to. Then what should this code here do? right? What should this code here do? And the answer is it should probably do what this arrow means, the definition of this arrow, and then continue looking at the rest of the code here, right? So what should an arrow do? I believe if we look here, it said increment the data pointer to point to the next cell to the right. So the data pointer is here, $pointer. So that's going to be, we'll take $pointer and add 1 to it, right? This is immediately going to fail because I need to make sure these are both mutable, right? Because we're going to be changing these over time. But I'm going to say the pointer here is mutable and plus equal to 1. And then what do? This is the real big brain part of this whole, this is the big brain part of this whole talk, really. The answer is we're going to do something like this. BF bang. And we're going to give it the tape. We're going to give it the pointer. And we're going to give it the rest of the tokens. All right, we're going to sit on here for a second. We're going to sit on here and make sure we understand this idea. So if we get a right arrow, increment the pointer by 1, then call this macro again. We're going to feed it the tape and the pointer again, right? We need to keep track of those across all these macro calls. But the difference here is that the rest was whatever was after this right arrow. We've dealt with the right arrow, and then there's the rest. So notice I'm not writing right. This would just be an infinite loop here. If I put the right arrow in again, it would just sort of keep going into itself. We've actually made a little bit of progress here. We've made a little bit of progress. Let me see. So the macro is death repeating. Yes, that's really weird and magical. So you'd say that, but I'm physically sure I'd probably just do it like that too. Oh yeah, actually that would have been smart as well. How does Rust prioritize tokens? E.g. a rule tokens TT star ident. How would Rust handle a token tree with semicolons? So yes, there's some rules about what tokens can follow, some captures, but I can't remember what they are. The answer is there are certain formats that the compiler will go, I'm not going to be able to decipher this. Therefore, I like will just compile fail and sort of drop here. In that case where you have TT star semicolon ident, it might be able to resolve that. But basically, if there is an ambiguity and it's not going to be able to resolve it, then it'll just fail. You'll get a compiler error and it'll go, no, that's not a valid macro. I probably just open Python. Yeah, and Python, that's a good one as well. Cool. Okay. So this is the big idea. Spit out a little bit of code that is sort of like makes a bit of progress and then continue on with the rest. And we can even see this in action right now. If I go BF bang, I give it the tape, I give it the pointer, and I say right arrow, right arrow, right arrow, and then just like this rule will end up catching anything that doesn't get caught by this. So I just go like foo, something like that. Oh, these are warnings. Yeah, whatever. This is the classic, do we want to throw in the allow unused, blah, blah, blah. I'm just going to do the lazy thing here, which genuinely is just the lazy answer. The other one is probably, the other answer we saw before is probably better. But, wow, warnings all disappear. Crazy. If I run cargo expand on this, we're going to get all this printing stuff. Oh, come on. There we go. Got to the top. Let's see here. We have create the tape, create the pointer. That's real code that we wrote here. Then pointer plus equals 1 from this, pointer plus equals 1 from this, pointer plus equals 1 from this. And then this foo here turned into this. Foo at the end was just like println bang stringify of foo. It just prints out a string that's called foo. I could have put whatever here and it would have caught it there. So we're sort of getting some Rust code starting to get spat out that looks a little bit like Brainf. Amazing. And the brilliant thing here is this is sort of modularized the work as well. We can just like keep going. So I'll grab this. How does a left arrow work? It's the same, but it subtracts 1 from our pointer, right? We're like a quarter through the language, right? A quarter through the language. What was the next one? Plus and minus. Increment the byte at the data pointer, decrement the byte at the data pointer. Easy. Plus, I'll put them both in first. Plus and minus. And what does this mean? It means the tape of the current pointer should be increased by 1. Right? And similarly, the tape of the current pointer should be decreased by 1. plus, minus. And again, just keep doing whatever comes next. Keep spitting out more code that means like whatever, that is whatever like the rest here represents, right? We are halfway through the language. Halfway through the language of Brainf at this point. All right, so what comes next? Outputting the byte at data pointer, inputting the byte at data pointer. This is a little tricky because we have to write the code that outputs and inputs. And I'm going to, we'll grab this. This is a dot for output and then comma for input. The code here is a little gnarly. In fact, I might even just grab some code here. Let's go like this. Tape. Like this. So grab the current byte, right? Grab the current byte at the current pointer and cast that to an ASCII character. It's not really ASCII, well, sort of. Rust is a little complicated here, but let's just pretend ASCII character and print it out. This little bit of code here is just flushing standard output because often standard output will wait for a new line. It'll buffer up a whole bunch of characters and then it'll see a new line and go, okay, great, I'll spit them all out now. We want to make sure it just prints character by character and, just in case, so we can see progress and stuff like that. So I've just got a little bit of code here that says flush standard output. It'd be nice if it was shorter, but Rust, so we've got to deal with that. And then reading as well is a little bit of a pain sometimes when I just want to say literally read a byte. So I'm going to bring some code in here for that. And this here just says read a byte from, so go standard input. We're looking at bytes instead. Grab the next byte, assume it exists. If there was no more bytes to read, just spit out 0. This is another one. Some Brainf programs expect EOF to be 0. Some expect to be 255. I've got a couple of programs lined up that expect it to be 0, so I'm going to leave it as that. So we've got the byte, and then what do we do with it? We say the tape at the current pointer is going to be equal to the byte that we just got out. All right. So there's a little bit of gnarly like Rust stuff, Rustisms to print the byte out and to read the byte in. But at the end of the day, this is the most important line here, which is just a simple one-liner. This is the most important line here, which is again, just a simple one-liner. And again, 75% of the language is done now. The last thing we have left, right? The last little bit is just looping. And the brilliant thing is looping may potentially be one of the, I think it's honestly the coolest one of all of these. And it's actually really, really simple. So the idea here is, what is our macro going to see in a Brainf loop, right? We have a left square bracket, a whole bunch of stuff, and we need to find the matching closing square bracket, right? But I mentioned something earlier. The thing I mentioned earlier is that macros in their input require that that any brackets, parens, braces, whatever, in the program are perfectly balanced, right? You can't just have an extra like square bracket flying off here, or like the compiler will actually reject it. The reason the compiler will reject that is because the compiler is doing the balancing for us. The compiler needs to actually know this one matches this one, that one matches that one, this one matches this one. And that makes this next thing so awesome. Oh, I forgot a semicolon off the end here. If I want to look for a square bracket loop in Brainf, all I have to do is write square bracket. That's the start of it. There's going to be a matching square bracket somewhere later. And Rust is going to make sure that these are balanced so that they've already got the correct order. So therefore, there's just going to be some body of tokens. I don't know how many there'll be. There might be 0. There might be, 1 or more, whatever. So I just say, grab me a whole bunch of tokens, as many as you want, and it will make sure that these two are balanced here, and I've just got a whole body of stuff to do. And what do I do in that body of stuff to do? Well, I say the rule from Brainf is if the byte at the data pointer is 0, then instead of going onto the next thing, jump to the command after the matching thing. Like if we look at the C equivalent down here, it's really just saying while this is not equal to 0, the current thing in the current like byte in the tape, do the stuff inside, right? And how do we write that in Rust? While the current byte in the tape is not equal to 0, do the stuff inside. The stuff inside is tokens because it's Brainf, as we know. So I'll say Brainf. And I give it the tape. I give it the pointer. And then I just give it the body, right? I need to say repeat for each of the body, things in the body. Do the body, right? And when this while loop ends up, you know, evaluating to 0, what's it going to do next? It'll do the rest of the tokens. Sorry, I forgot the dollar tape, dollar pointer, and the rest of the tokens. Star. That's looping. That's essentially 100% of Brainf. There's one last little case here that we've actually missed off, which is eventually we're going to run out of tokens, right? And that's great news. That means we're coming to an end. And what that'll look like is we'll still have the tape, we'll still have the pointer, but then we'll have nothing afterwards. There will be no tokens here. So there's no tokens here. I'll just leave it empty. And this is actually the entire definition. I'll write a comment here saying no more instructions, or maybe no more commands, based on what's called in Wikipedia. This rule here is now complete. We don't need that anymore. That was just sort of a leftover of what we had before. And brilliantly, notice that it looks like it's actually figuring some stuff out, because this foo here is an error. It's saying, I don't know how to deal with foo. If we get rid of it, suddenly, oh my gosh. All right, I'll get rid of hello world for a second. Let's see what it does. So cargo run, it's not actually going to do anything at this point. Oops. But if I say cargo expand, look at this. Arrow, arrow, arrows turn into pointer plus equals 1 plus equals 1 plus equals 1. Right? What if I throw in like a arrow plus arrow? Then what do we expect is going to happen? It's going to spit out code, Rust code, that says add 1 to the pointer. The thing at the current pointer is added 1, and then that. Right? What if I said, so go right plus plus plus, like that, and then print out the current byte. Actually, this is probably no good because it's going to print out maybe the ASCII character 3. So let me go like, let's do I'll just hold it down for a while. That'll probably be like a real ASCII character, right? So add a whole bunch and then print it out. So this here turns into a whole bunch of plus equals 1s and then a bit of printing here. Cargo run, and that's a % symbol. That's cool. If I like take off, if I shave off a couple of these, I'll probably get something like hash. Great, right? I took off 2 of them. If you go 2 down on your keyboard, $$ hash, and yeah, you get a hash out at the end. Okay. Now, the big test here. What about hello world? Right? Oh, it doesn't know it. I renamed these. Right? Hello world. Run it. Wow. And how is that? Does hello world appear at all in the Rust source code? No, of course not. It's all just like garbage Rust code that's doing like nothing. Look at this. This is so cool. The square brackets here, right? This square bracket has turned into a while loop that has all this stuff on the inside. We've got 1, 2, like nested. There's this one here. That's this square bracket here, this square bracket here. This little while loop here is just one thing long. It's incredible. But this sequence of Rust code, right? Because we made it follow the rules of Brainf, and someone's written us a valid Brainf program that prints hello world. When we run it, it prints hello world. It's amazing. There's still a little bit left to be desired here, and we've still got a little bit to go in improving what we've got. So the things that I don't like with what we've got so far is that white space, right? I need to put white space between each character here. Not every single one. So for example, there's no token that consists of multiple pluses. So if I put a bunch of pluses together, Rust is going to be happy with that, and it's going to spit out hello world. But a token that does exist, for example, is an arrow, right? This dash and then an arrow, and it goes, I don't know what this arrow means. Like it goes through all our rules and goes right arrow, left arrow, plus, minus, dot, right? But there's no actual like dash, you know, this. There's this, but there's not this. And that got tokenized into one thing. So when we run it, we actually get an error going, I don't know how to deal with this. No rules expected this. right? There's actually a relatively nice workaround to this. There's also one other thing I don't really like. And that's that I have to do this stuff here and this stuff here. I don't really want that. I'd rather just write not have written this, just give it BF code, no spaces in it, right? And it just does brain frick. It spits out Rust code, right? That's what I really want here. And we can also do that. So how do we do that? The answer is, so let's do this one first, the tape and pointer stuff. The answer is much like the vec macro that we made earlier on, we're going to add in an extra rule down the bottom here, right? This rule should only match if none of these rules matched here, right? And these rules won't match, right? If they've got basically, if they don't have a ident, semicolon, ident, semicolon, blah, blah. So if I just get a whole bunch of tokens, right? And let's say, do we need to say 1 or more? Or do I want to say 0 or more? I can probably say 0 or more in this case. If I've got a whole bunch of tokens, implying as well that none of these ones matched, they've probably just given me straight up brain frick code right here. So let me take this stuff that we wrote earlier, right? Create a tape, create a pointer, and then hop into the main sort of body of the macro by giving it underscore tape, semicolon, underscore pointer, semicolon, and then all the tokens. Right? So now it's actually complaining. What are these? I don't need these. Right? We don't do, so the first time it doesn't match any of our above rules. So it gets down to this one. It creates a tape, creates a pointer, passes these into it calling the macro itself. Suddenly there is an identifier, a semicolon, an identifier, a semicolon, and a whole bunch of tokens. So it starts matching these rules up here, which starts spitting Rust code out until eventually it's only got the tape, the pointer, two identifiers separated by semicolons, and nothing more. And there's no more to go. It doesn't recursively call itself anymore. It just goes, I'm done, and it stops spitting out Rust code. So let's see if this still works. Cargo run, hello world. Cargo expand. Scroll, 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 scroll. Maybe I can do, oh, there we go. We're already at the top. You can see it expands first into this stuff and then starts doing all the macro magic. Brilliant. All right. And yeah, you could actually do a wrapper macro. So maybe you don't want users to accidentally run into any of these cases themselves. You only want this format. And so it's not super uncommon to see like this being the BF macro here and then having like a BF underscore internal macro that users don't actually end up seeing. But we could also just shove it all in the one and it works as well. And so we'll leave it as it is this way. The last one that we need to do here is deal with these pesky tokens, right? Again, if I join together two tokens like this, it goes, that's a bitwise shift. I don't know how to deal with that. And in fact, now the error is popping up here because it matches this. And then this goes, once it actually recursively calls itself, it doesn't know how to deal with it anymore. So how can we do that? How can we deal with this rather? There's actually a really nice way to deal with it. So I'm going to say appease the parser. And I'm just going to add some more rules. What are these rules going to look like? Well, I'm going to say tape, ident, because we got that. We've got our pointer, which is an ident. And then I'll throw in the rest here as well. $rest is a token tree. And what I'm going to do is if I see something like this, right, a bitwise right shift, which really what I want it to mean is a single right arrow and a single right arrow, oops, semicolon. Then what I want you to do is go BF bang of $tape, $pointer, and then this is the magic, right arrow space right arrow, two separate tokens, right? And then we could throw the rest in here as well. Oops, $rest like this, right? So this almost just like translates when it sees something that looks like a bitwise right shift, it almost like fixes it back up, puts a space in, like goes, no, these are two separate tokens, and then feeds it back into itself, right? Rust will not see this as a bitwise right shift because a bitwise right shift needs to be arrow, arrow, not arrow space arrow, right? This is really two like greater than symbols. And we end up just having to repeat this little, this little trick that we've done here for each of the cases that are giving us trouble. Let me, oops, that's not what I want to do. Grab it like this and go pop, 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 pop. So what are the ones giving us trouble? A left shift would do the same thing here. A arrow pointing to the right will give us trouble here. An arrow pointing to the left will give us trouble. And dot dot, well, we really want that to actually mean a single dot and a single dot. I believe, if you can think of any more, let me know. I believe those are the ones that cause us issues. Right? And then if I take all this and get rid of all the white space there. There we go. Actually, I probably want to make all this indented once more. We'll see. This all turns into one thing. And we get hello world. Right? Because when the parser sees like maybe that's a right arrow there, it ends up feeding it back into itself into just a dash and then a right thing. If we look at cargo expand one last time, you'll see like there's no sort of special machinery and it's not doing any of this work. It's not sort of like this is not a program that's taking in these characters at runtime, right? It's not a program that's taking this as a string and going through it one by one. It's like the compiler has generated Rust code that is equivalent to this Brainf code. This macro, Brainf, is a transpiler. It's a transpiler from Brainf to Rust, right? Much like this Wikipedia article said, you can transpile or translate Brainf into C by following these patterns here. This is Brainf transpiled to Rust, which is just it's just absolutely lovely. I've got this. That's about the end of our lessons. That's the macro done there. But I think it'd be, now is certainly not the time to leave just yet because I want to show off a couple examples of our code doing some fun stuff. So that was Hello World. The next one I'm going to pull in here is, rot13. So this is a real fun one. Rot13 is a very simple encryption method. It's a special case of a Caesar cipher where it just rotates each letter by 13. So if I go cargo run and I give it, oh no. Oh, yes, interesting. I forgot this one. Attempted to subtract with overflow. I mentioned this at one point. I said that if you subtract like 0 and you say -1, it should actually wrap all the way around, right? It should wrap all the way around and go to 255 in this case. So I actually need to change this to instead be +=1. I'll do wrapping add of 1. And over here, I'll do wrapping subtract of 1 as well. Completely forgot about that one. Oh, and I actually need to then say $tape of $pointer equals this over here. So this is saying, yeah, don't just say +1 because that'll panic if it overflows either way. Instead, I say no. I explicitly want it to wrap around. So now, if I say hello world, or actually even hello world, you'll see that the Brainf spits out this. And in fact, just to make it very clear, I will kill the program and run it again. If I feed it this, it spits back out hello world. So this is a rot13 cipher, which is very good fun. And again, this is all like crazy Rust code doing this in the background, which is just super fun. I've got 2 more programs here. Oops, that's not what I wanted. That's what I wanted. This here is a Brainf program that computes E, right? And this is great because suddenly, no, our program breaks, right? This is a program to compute digits of E, but there's so many sort of nested levels of loops in the macro calling itself that Rust has decided this program's no good. I won't compile it. And this is to sort of, this is a brilliant consequence of Rust's type system, and in this case, the macro engine. Well, so how do I say this? Rust's type system is Turing complete, which is absolutely brilliant. And so, but also there's just these macros that could potentially, you could make a macro that just loops forever, and they don't want the compiler to ever just like loop forever and ever and ever, because you won't even know what's wrong with your program if it's even building or not. So compilers have an idea of, Americans would call it gas. In Australia, we'd probably call it petrol, I suppose. They have this, compilers have this idea of petrol, let's say, where every time they sort of do a little bit of work, they'll subtract 1 petrol from their tank. And eventually, if they're just doing so much work over and over that they don't think they're getting anywhere, and they run out of petrol, they go, too much. I think you've done something wrong. In our case, we know we've just done something horrible, but certainly not wrong. And so we can explicitly say, no, add more petrol to the tank, right? I've actually got this window up over here. Limits here. There is a recursion limit attribute. The default in Rust C is 128. Let's go sicko mode on this recursion limit and set it to something like 1024. So that means like add a bunch extra petrol to the tank, like we're going on a ride here. And if I go cargo run now, how good is that? 2.718, 2818, you know, blah, 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 goes on for ages. And eventually thread main panicked because it ran out of room on the tape, right? The tape isn't quite infinite. And this will just keep calculating digits of as much memory as you give it. And so that's just brilliant as well. If we upped the tape size here to say 4096, then it would spit out more digits of E and then eventually panic as well, which is just, that one's just so much fun. Let me catch up on the oh, rip camera? Camera looks, oh, it went autofocus for a second. Yes, okay. As soon as I looked back at it, it was like, oh no, he's going to find out, and it focused again. Okay, I've got one final example, which I think is the coolest one of all time. But I'm going to catch up with the chat before, and then we'll end the stream. So let's see. Reminds me of C++ substitution error is not a failure thingy. Any nice way to wrap the pointer itself when it hits 2488 or 0? So you could do that as well. I could change these to I could sort of add some logic in here that goes if the pointer has reached the end, wrap around. But most Brainf programs are not expecting you to do that. They're expecting if they keep going one direction, they'll keep getting more memory. So actually a panic I'm perfectly fine with here because it's just saying I ran out of memory essentially. If we didn't do that, it would start having incorrect results because it would run into old memory or something like that. I think that makes, yeah, correct. As perniciously purple as pointed out there. All right, the last one and my absolute favorite. This is actually a throwback or a callback rather to earlier on in the stream. I mentioned this thing existed here and now I'm bringing it in. This here is the mother of all Brainf programs, right? It goes on and on and on and on. This is a Brainf interpreter that I mentioned far earlier. So I need to comment out the E example. This is a Brainf program that takes as input a Brainf program and executes it, like does what it should. So they've essentially done all the work we've done here in a certain sense, but in Brainf, which is just so cool, right? There is so much going on here. And just to properly credit this one, this was when I brought it up earlier here. This, I believe, is, I think they say this is likely the first Brainf interpreter written in Brainf. And it's seriously so cool. So here's what I'm going to do. I'm going to grab the hello world code from earlier. What's the best way for me to do this? I will grab it like, I'll go set no number. That's fine. I'll grab it like this. Paste it into my term, and then I'll just patch it up here. I'm scared of doing Control W because I might lose. Let's do echo all of this into delete spaces. And let's also delete new lines. All right, great. There is hello world. Copied onto my clipboard here. And if I cargo run this, I've still got E. I didn't save the file probably. Yeah. If I cargo run this one is like, look how long this takes to build. Because think about it, this is a lot of Rust code that this macro is spitting out. And the compiler is having to go through and work through all that Rust code, right? And then it's sending it off to LLVM for it to compile into machine code. There's a whole bunch of code there, but it's done now. If I paste in hello world, and this program, they say here, it expects, this interpreter expects as input a Brainfrick program terminated with an exclamation mark. So I'll terminate with an exclamation mark. And if I hit enter here, it thinks and it prints out hello world, which is just so cool. So cool. Run the interpreter in the interpreter. I like, based on how long it first of all took to build, but then took to just print hello world, I think going, need an exclamation point. I think going 2 interpreters deep might be, it might be a bit much for it. So I'll probably put it out of its misery there, but I will put this code on Git. And please do see if you can get that to work. See how many interpreters deep you can go, as if you want to play around with that. But yeah, seriously, like, this is a very cool piece of software that this person has written here. And yeah, that is the very cool example at the very end to end it off. I'll leave us with our hello world here. I'll push this to Git now. So let me go create a new repository. Here, repositories, new. We will call this BF stream, something like that. It is public. We don't need any of this. And I will yoink this, git remote add origin, git add dot, commit-m, stream finished. Git push -u origin main. And there we go. I will drop this in the chat now. I've got a chat over here. And there we go. Run a Rust compiler in Brainfrick and then compile the Brainfrick macro in the Brainfrick Rust compiler, then run the Brainfrick interpreter with the Brainfrick macro by the Brainfrick Rust compiler. That's next stream. Yeah. All right. Well, that'll do us off there. Is there any questions before I close off the stream, before we're done for today? And thank you everyone for making it out. I hope this was a little bit fun and maybe like slightly educational, but at least a little bit fun. Is there any questions before I end it off? Oh, awesome. What's the next stream topic? I do have an idea. This is when I came up with this idea for a stream/talk thing back in March, I mentioned. And at the same time, I also came up with another idea to do. I really want something with similar semantics to scanf in Rust, and there's not really a great. I've looked at all the crates that offer something like that, and they're all slightly wrong compared to what I want. So I was thinking of doing a longer format stream, where I create a new crate for crates.io, like a new crate for public use, that sort of brings a scanf like thing from C to Rust that works in really like what I'd consider to be a correct way, because they're all subtly broken. And the way I can very quickly explain that as well. If I give like input that looks like 1, 2, 3 in C, if I say scanf %d in a loop, I'll get 1 first, then I'll get 2, then I'll get 3. In every existing thing, it wants to read the whole line, and then it'll go 1, 2, 3 is not a number. You would actually have to feed this into your terminal as 1 new line, 2 new line, 3 new line, which is just kind of silly. I think it should work if you just give it this. And also I want it where the scanf stops right after the number and there's a space next, as opposed to having it chomping 1 space and then 2 space for each one, which is an even more slight semantic difference, but it drives me a little crazy. And I also need it for MIPSI. MIPSI is slightly broken because of there's no good sort of option for this yet. So I was thinking of doing a stream where I make a real world crate and go from like having nothing to having a published, documented, publicly available crate for Rust crate on crates.io. So maybe that, but I'm not sure when I'll have the time or the energy for that. But if there's interest, then I can certainly have a think about streaming that. The next topic is called 6991 Week 0 Rust Toolchain. I've already recorded that, actually. That exists on YouTube, but is unlisted. I think you'll have to wait till week 0 before you end up finding that one. All right. I think we'll end it there. Thank you, everyone. Thank you once again. And yeah, I'll see you all next time. Bye-bye.